Question 14. We're shown a triangle and it says the pilot of an aircraft wants to fly from A to D. The aircraft flies from A to E 1 degree off course. And we're showing that this is not drawn accurately. That seems quite big for 1 degree. And the distance BC is 1 mile. Work out the distance of DE, which is this distance here. So what we should recognize is that this is two similar triangles. We have the smaller triangle here, which looks like that, and we have the big triangle here. Now, both triangles have the same 1 degree angle. We know in the smaller triangle, this is 1 mile. This we don't know. And we know on the smaller triangle, this distance is 60 miles. Whereas on the bigger triangle, remember, it's the whole thing. It's a 60 plus 150, so it's 210 miles. So with similar triangles, we're trying to work out the scale factor. So 60 times what gives you 210. And once we know that, we can then use that scale factor to times this by the scale factor to give you the distance here. So this might be quite difficult to work out, especially without a calculator. But if you imagine it said it went from 60 to 120, you'd hopefully say the scale factor was 2, because 60 times 2 gives you 120. So if you think about how you get that 2, 120 divided by 60 gives you 2. So obviously we didn't have 120, we had 210. But basically the method is the same. We have to take the bigger number, divide it by the smaller number to give you the scale factor. So 210 divided by 60, it gives me my scale factor. And straight away I can do some cancelling to get rid of those zeros. 21 divided by 6. Well, 6 goes into 21 3 times. 6, 12, 18. And 18 up to 21 is a remainder of 3. And because I was just dividing by 6, I put that over 6. So it's 3 and 3 6. And 3 6 is the same as a half. So that means my scale factor is 3.5. So in other words, 60 times 3.5 or 3.5 gives me 210. So now I know that's my scale factor. I can then do the same for this. 1 mile times 3.5 would therefore give me 3.5 miles. So that's my answer. In part B, it then says, how should the aircraft have turned at C to drive directly towards D? So let's have a think about this. So remember, the aircraft goes 1 degree off course, taking it to this point. I'll draw another straight line at that point. It will continue going 1 degree off course at C, taking us up to E. The question says, how should the aircraft have turned at C? How should it turn at C to fly directly towards D? So there I am at C. I want to go directly towards D, which is down in the corner here. Remember, this is not drawn accurately, so this looks like a really big angle, but actually it's not very big. So at C, at the moment, I'm going 1 degree off course. So if I go 1 degree off course the other direction, I then go back to a straight line. I then want to go another bit, the way off course, to take me to D. And if we apply a bit of logic here, this distance was 60 miles, this distance is 150 miles. So I will need to turn more than 1 degree to make sure I'm pointing towards D, but it's not going to be as big as 1 degree. So it's going to be between 1 and 2 degrees. If it was more than 2 degrees, it would take me towards D quicker, so less than 60 miles. But because I've got 150 miles to get there, I need to go more than 1 degree, but not that much more. So I'm going to say my answer is between 1 and 2 degrees.